Good day, everyone. I am Joel T. ASUBAR of University of Fukui, and this is a video introduction of our university's Department of Electrical, Electronic, and Computer Engineering, and particularly our laboratory, Electron Device Laboratory. To begin with, let me say something about Fukui. Fukui Prefecture is located strategically in the center of Japan along Japan's seacoast. By express train, Fukui is 1.5 hours away from Kyoto, 1 hour 57 minutes away from Osaka, 2 hours and 10 minutes away from Nagoya, and 3 hours and 26 minutes away from Tokyo. Places of interest in Fukui includes the Ono Castle, which is a real-life castle in the sky, Tojimbu Cliffs, which are rock formations sculpted millions of years ago by erosion and waves from the Sea of Japan, Ichijodani, which is a castle town of 15th century warlords, and of course, Fukui Station, with its open-air exhibit of Fukui dinosaurs. Fukui Prefecture is actually home to Japan's most prominent dinosaur fossil discovery site and houses one of the world's largest dinosaur museum. Now, talking about our university, University of Fukui has three campuses. Matsuoka Campus, housing the medical sciences, Bunkyo Campus, housing the education, engineering, as well as the global and community studies, and Tsuruga Campus, housing the Research Institute of Nuclear Engineering. All in all, we have four schools of undergraduate programs, namely education, medical sciences, engineering, and global and community studies. Under School of Engineering, we have five departments, namely Department of Architecture and Civil Engineering, Department of Electrical, Electronic, and Computer Engineering, Department of Mechanical and System Engineering, Department of Applied Physics, and Department of Material Science and Biotechnology. As the largest school of engineering on the west coast of Japan, we offer a wide range of courses and programs. Our education program conforms to Japan Accreditation Board for Engineering Education, or JABI, standard. And we contribute to the development of local and global communities by producing what we call global Imagineers. Imagineer is originally coined word from imagine, an engineer. Imagineers are highly skilled engineers who can imagine their dreams and realize them through engineering. Now, let me talk about our laboratory, Electron Device Laboratory. Our laboratory has been doing research in gallium nitride based devices. Compared with silicon, which is a widely popular semiconductor material, gallium nitride is a compound semiconductor whose bond length between constituent gallium and nitrogen atoms is smaller than the bond length between silicon atoms. Smaller bond length means that the bonding energy between constituent atoms is stronger. And this leads to higher critical electric field of gallium nitride compared to that of silicon. Critical field is the minimum voltage per unit length that causes breakdown in a given semiconductor device. And because of the high critical field of gallium nitride, for same breakdown voltage, a shorter gallium nitride device compared to silicon device can be fabricated. And why is this important? I tell you why. This slide shows the simplified process flow of energy conversion from primary energy sources to energy that can be used by the consumers. From primary sources, energy is converted to different forms before it is delivered to final consumers. For instance, voltage generated in power plants are typically in kilovolts, but our cell phones need just 5 volts, and our laptops charge at 15 volts. Generally, there is a need to step up, step down voltage, or change its frequency. However, in the process of power conversion, a huge amount of energy is wasted. This loss is due to low conversion efficiency of power devices. Today, much of this loss is due to intrinsic limitation of silicon, which is the semiconductor material from which the devices are made up of. Energy loss is power P times time T, and power P is current squared times R. The higher the resistance, the higher the energy loss, meaning to minimize energy loss, the resistance of the devices should be minimized. Now, the big question is how to minimize the energy loss in power devices. Again, resistance R should be minimized, and we can do this by employing gallium nitride devices. And how is that? Resistance R is given by this equation, which means that we can decrease R by shortening the length of the devices. However, shortening the length will make devices prone to breakdown. For a constant applied voltage, a shorter length will lead to a stronger electric field across the device. And when this electric field exceeds the critical field that depends on the material, then breakdown happens. This is where the so-called wide bandgap semiconductors, like gallium nitride, come into picture. As we can see, gallium nitride has almost 10 times larger critical field than silicon, which means that for the same breakdown voltage, a device made from gallium nitride can be made much shorter compared to a device made from silicon. And this leads to lower resistance and therefore lower energy loss. Let me introduce now the aluminum gallium nitride high electron mobility transistor, or simply AlGaN, which is one of the widely studied gallium nitride based electron devices. Strong polarization fields in the AlGaN heterostructure result in a sheet of very mobile electrons, which tend to gather along the Algan-GAN interface. This combination of electron density and mobility can facilitate low resistance and high power operation. However, there are still issues in these devices, such as stability, safety, and not reaching its full potential. In our lab, we are engaged in the research of Algan-GAN state-of-the-art devices, aiming to push their performance towards their theoretical limit. Among Japanese institutions, our university is one of the top institutions in Japan in terms of published papers on Algan-GAN hemps. This is in spite of the fact that our laboratory is relatively compact. And as of now, we just have 6 graduate and 3 undergraduate students, total of 9 students. And of course, it's not just the quantity, but also the quality of our research outputs. In 2020, we reported an unprecedented combination of threshold voltage and drain current in our Algan-GAN hemps fabricated using University of Fukui original Yamamoto regrowth technology. This paper was included in IEEE Electron Device Letters Popular Documents in April to June 2020. In collaboration with Kumamoto University, we also demonstrated the first Algan-GAN hemps using alumina insulator deposited by non-vacuum, low-cost, and environmentally friendly mist CBD method. I would like to mention that this device was fabricated by an international student, Rishan Low, who during that time was a first-year master's student in our laboratory. This research was the most read paper in Applied Physics Express in February 2021. This work was also highlighted and introduced in UK-based Compound Semiconductor magazine. As a matter of fact, works from our laboratory have been perennially highlighted in Compound Semiconductor magazine, such as our discovery of electroluminescence and stability correlation in GaN-based hemps, demonstration of 5 kilovolts GaN-based hemps using gallium nitride substrates, oxygen plasma surface treatment for highly stable gallium nitride-based hemps operation, to name a few. In January 2022, our invited tutorial paper on controlling electronic states in gallium nitride-based transistors, which is a collaborative work with Hokkaido University, Nagoya University, Kumamoto University, and Slovak Academy of Science, has been included in the most read tutorials in Journal of Applied Physics. All of these are testaments to the commitment of our university for world-class research and education. Lastly, I would like to show you some facts and figures about Fukui Prefecture and University of Fukui as well. According to the results of the National Happiness Index, Fukui Prefecture has remained Japan's happiest prefecture. Meanwhile, University of Fukui has overall satisfaction rating of over 90% according to our exchange students. Also, the university offers scholarships and support prior to your arrival in Japan. As for the career path, half of our foreign student graduates either pursues higher education or settles for a job in Japan. And so, if you are considering studying in Japan, the University of Fukui is waiting for you.